Dear students, today we will discuss how to find out the dipole moments. For the find out the dipole moments, we have several types is there for find out the dipole moments, but we have discussed only vapor temperature method, and second method is the dilute solution method. For these methods, we require the formula, that is the total polarization. That formula we have derived in a previous lecture, that is a molar polarization or total polarization present in the polar molecule. Okay, without applying the electric field to the polar molecules is randomly distributed, and when we apply the electric field, okay, for this molecule or for the polar molecules, when we apply the electric field, that electric field, okay, suppose we apply the electric field, that electric field apply a torque to this and try to originate that polar molecule towards the direction of electric field. Okay, and first thing, that electric field is produced in our polar molecule is there is a distortion of the charges takes place. Okay, charges goes away, that is the positive and negative charges maximum take apart to each other. That is the first effect, impart that electric field to your polar molecule. Okay, therefore this distortion of charges due to the electric field, already it is a polar molecule have the positive end and the negative end. Okay, but they are the nearly situated to each other, separation is the less. Therefore, by applying the electric field, they get maximum apart from each other. Okay, that type of the distortion of the positive and negative charge we have discussed already. This is called induced polarization due to the distortion of the charges, and induced polarization is given by 4 by 3. Pi is the constant, n is the Avogadro's number, and alpha is deformability or the polarizability of polar or that molecule, whether it is polar or non-polar. Okay, induced polarization only found in non-polar molecule. Okay, first effect, induced polarization is produced in our molecule. Okay, therefore we need to find out the total polarization or total molar polarization for these polar molecules. First effect, the charges is distorted by the electric field, then that electric field try to this polar molecule to pulls positive ends towards the negative end, and negative end pulls to the positive end. But this molecule have the some energy is there, that is a thermal energy. It is having the some temperature energy, that is thermal energy. Due to that thermal energy, that molecule or that polar molecule try to oppose to take to this electric field. Okay, therefore it orients, but it's very slightly turn. It takes very slightly turn. Okay, just it turn due to that force, but it also opposes that electric field, that which is having the permanent dipole. Okay, this effect we only see in that orientation which molecule has the permanent polarization, and the permanent polarization is present only polar molecule. Therefore, then due to this, it tends to apply a torque on this non-polar molecule, and it try to pull that molecule towards the electric field. Okay, that is the direction of electric field. Okay, try to make the like that rotation and try to it try to like that position. It try to that electric field try to effect on that polar molecule. But this not takes that position. It takes the position in between its original position. This is its original position. That is its original position. Okay, this is original position. Okay, after that electric field apply the torque to this, it takes some its slightly turn, but it's not totally turn, not take the horizontal position to the field of electric direction. It remains in between because it is having the thermal energy. Okay, temperature energy is there, and due to this it vibrates, and that's why it not take the position totally horizontal to the direction of electric field. Okay, therefore that polarization due to the position of polar molecule is called as the orientation polarization. Okay, it takes the in between the place in between the electric field require the its electric field require like that its orientation, and its original position was like that, but it takes the in between position of these two and remains stable like that. Okay, therefore that due to that orientation we have obtained the second polarization. Orientation polarization is equal to 4 by 3 pi n, and that polarizability for orientation is equal to, it depends upon mu square upon 3 kt. Okay, that is a constant, that is Boltzmann constant. K is the Boltzmann constant. Your polarizability is depends upon the permanent dipole moment and the temperature. Remember that. Therefore, you replace this, you will obtain mu square upon 3 kt. Okay, therefore, in polar molecule, total polarization and molar polarization is given by P naught, that is orientation polarization and induced polarization, and it is equal to 4 by 3 pi n alpha plus 4 by 3 pi n mu square upon 3 kt. Okay, that equation we have to use for the, okay, that is a square, it is, remember, it is a square one. That equation we use for the find out the dipole moment by using the our vapor temperature method. Okay, use that equation, that total polarization will equal to 4 by 3 pi n alpha plus 4 by 3 pi n mu square upon 3 k. Okay, that t we take away from that particular equation because t is only variable. All the quantities, pi is the constant, n is the constant, alpha deformability is the constant. In this case, pi n is the constant, dipole moment is the constant for a particular polar molecule, and k is the distribution constant. Okay, the total polarization we have given, or that is the equation. Okay, that quantity will becomes equal to the d minus 1 d upon d plus 2 m upon d molecular weight or molar volume upon density. That particular formula we will use in our find out dipole moments in the method, that is a vapor temperature method. Okay, now that total quantity is a constant quantity. Okay, therefore for this quantity we will introduce, in this place we use the A. For this quantity we use as a B. 1 upon T is the variable, and it is your total molar polarization, and this is equal to this quantity. Remember that total molar polarization is nothing but the D minus 1 D plus 2 M upon D. D is the dielectric constant. This dielectric constant we have already discussed in the previous lectures. Okay, now actually we will do the experiment and find out at a different temperature, different molar polarization, because the in polar molecule polarization is depends upon the temperature, because due to thermal agitation molecule oppose to take the position in the direction of the electric field. Remember that. Therefore its variable temperature is varies, your total molar polarization is varying. Okay, we try the experiment at T1 temperature, T2 temperature, T3 temperature, T4 temperature, and T5 temperature. We have find out the PT values for the different temperature. For a different temperature, D values and the density, we will find out the values and density for a different temperature. Okay, and put these values in this equation. If suppose T1 temperature, we find out PT is equal to D1 minus 1 D2 plus 2 M upon D1. Then second molar polarization part, the T2 temperature, D2 minus 1 D2 plus 2 M upon D2. Like that PT3, you will find out D3 minus 1 D3 plus 2 M upon D3. Okay, at every time it changes density, and this and PT values also changes. Okay, now we find out these values PT1, PT2, PT3. Then this is this equation compared to the equation of line y is equal to mx plus c. Okay, therefore we can arrange this equation. Y is equal to mx plus c, that is our intercept, m is the slope. Okay, m is our slope, and slope formula is the y2 minus y1. Okay, if you find out the graph, that is the formula we have to, and that is the intercept. Okay, intercept means to cross the line from x-axis, that value is the intercept. Okay, that compare this equation, y, that is our y is the PT. PT is nothing but we know that the d minus 1 d plus 2 m upon d. Okay, that PT we find out already by different temperature, and different temperature is equal to, that is our x, 1 upon t will be x, therefore we rearrange this, b 1 upon t plus a. By comparing this, y is equal to pt, m is equal to b, x is equal to 1 upon t, and c is nothing but the intercept. Okay, in this case slope is m and it is a positive one. Okay, if slope is 1, your direction of the graph will be towards the outside. Okay, therefore we try to, okay, we have already find out the p1, p2, p2. Okay, at the, that is y, at the y-axis we have taken the pt, at the x-axis we have taken the 1 upon t. Okay, therefore for T1 temperature, T2 temperature, 1 upon T temperature, 1 upon T, you obtain the straight line graph, because your B is the slope, you obtain the slope. Okay, at that point this line cut the your y-axis. This is nothing but your c. Value of c will be this. Okay, that is intercept. It cuts the y-axis at that point. That is the intercept. Okay. Therefore, the slope, we know that slope is equal to y2 minus y1. By using the formula, we can find out the slope. In this case, slope is equal to b. Slope is equal to b. Okay, by comparing, we have find out the slope. And this b quantity is nothing but that quantity. Okay, we have, instead of this, we use the b quantity. Okay, now b is equal to that one. Firstly, we write 4 by 3 pi n mu square upon 3 is the quantity of b. Okay, therefore, we are interested in to find out the dipole moment. That is mu square is equal to 3 into b. Okay, that total quantity will be go at that side. The 3 and 3k will be at upper side. Okay, that is the numerator side. Then at the bottom there should be, okay, mu square at the one side. At the bottom there will be the pi and the n, correct? And 3 into 4. Okay, at the bottom there is a 4. That 4 is the will come at the bottom. Okay, you can simply pi n. Okay, by writing that pi n. Okay, therefore 3 into 3k at the top side. Okay, at the upper side, and that your denominator, that is the 4 pi and n, and okay, that b will be at the, okay, that b will be at the, okay, that b is equal to slope. Okay, that is b is equal to, we have taken the slope, and the slope is nothing but the formula 4 by 3 pi n mu square upon 3k. Okay, all this quantity we take 4 by 3 pi n mu square upon 3k. Okay, like that we find out b. We find out the values of b. Okay, therefore that b b will be at that position. Okay, this all we transfer to this side. 3 into 3k 4 pi n. Okay, like that all this quantity at one side we only put the mu square 3 into 3k upon 4 pi n, and b is as it is. Okay, like that we find out that equation. Okay, now mu square is equal to 3 into 3, that is a 9k upon 4 pi n. Okay, therefore mu, that is b is there. Therefore mu is equal to under root 9k 4 pi n into under root b. Okay, then the total quantity of these, when we put the Boltzmann constant, that is Avogadro number and pi, it becomes equal to 0.01273 under root b. Okay, therefore by using this we find out the b. By put this b, you will obtain in the form of the deva. That dipole moment you obtain in the form of deva. Okay, that is the first method. By using this method, we can find out the dipole moment. Okay. Now, that is second method is that is solution method, dilute solution method. Okay, in this method, we are, if solid substance is there, okay, if gaseous substance is there is no problem. Gases directly we can find out its dielectric constant, but solid is there, then we have to use that solid, we have to prepare the solution, and that solid become your solute, and you add in the in non-polar solvent. Remember, you add the non-polar solvent. First thing you have to add, you have to find out the dipole moments for the solid. This method, dilute solution method, is used for the solid substances. Okay, therefore you take the solid substances and dissolve in non-polar solvent. Okay, therefore solute plus our non-polar solvent. Okay, you have to prepare these things. Okay, therefore you prepare the solution different concentration. Okay, different concentration you prepare the solution, and or if you prepare the solution and at different temperature, you find out its dipole, its total molar polarization. Okay, now we have the formula, that is the total molar polarization is equal to d minus 1 d plus 2 molecular weight upon density. Okay, therefore in this case we use the solute, its molar fraction is the n1 and its weight, if suppose, okay, that is n2 and m2 we use, and for solvent we use the molar, that is the molar fraction n1 and its molecular weight is the m2. Okay, therefore in this case we not use the single gas. Okay, if single gas is there, you put the m as it is. Okay, m, if suppose we use the gas, okay, O2 gas is usually 32, its molecular weight, we put this in this case. But we have used the solution, therefore the m is replaced by the n1 m1 plus n2 and the m. Okay, therefore if you have the solution, that mass will be replaced by that formula, that is molar fraction of the solvent, molecular weight of the solvent. n2 is the molar fraction of the solute and m2 is the molecular weight of the solute. Okay, therefore in this equation we will put this value, that is d minus 1 d plus 2. M is, we put this because we have used the solution. Okay, if solution is not there, only one substance, gases or liquid is there, therefore that is not replaced by this. For only solid substances, because directly we cannot find out its dipole moment for solids, therefore we have to make its solution in a non-polar solvents. Okay, CCl4 or benzene are the non-polar solvent, you take the solute and dissolve in the non-polar solvent. Okay, then D is as it is, density is the, for solution we can find out the density at a different temperature. Okay, now up to this we have came, and next is total molar polarization is equal to d minus 1 upon d plus 2, then that divide multiplied to this one, that is the m2 into n2, okay, n1 okay, sorry, n1 m1 and n2 m2, this multiplied to this, also density. Okay, therefore n1 m1 upon the density plus d minus 1 d plus 2 into n2, sorry, m2 n2 and d. Okay, for this sake of convenience we have written like that, m1 upon d and m1 upon d, because this quantity we have known that particular quantity. Okay, this quantity is nothing but the molar polarization of our, the one is our solvent, okay, for the solvent, that is P1 and En1, plus this is molar polarization of the solute, that is a P2 and a En2. Okay, polarization P1 is the polarization for solute, solvent, and P2 is the polarization of the our solvent. Okay, therefore we are interested in to find out the polarization of the solute, because that polarization we have not known because it is solid one. That's why we are make the its solution to find out the its polarization. Okay, therefore that is Pt minus P1 N1 upon that's N2 is equal to P2. Okay, that P2 is nothing but the polarization for the solid substances. Okay, therefore we have find out the polarization of solid substances. P2 value we have find. Okay, that Pt is the total polarization. We can find total polarization, and by knowing these values, that P1, N1 and N2, you can find out the P2 values. Okay, that is the polarization of. Okay, now by using the previous formula, mu is equal to 0.1213 under root b. Okay, that is the b is the slope. Okay, the P2 values we have find out for the different temperature. You have to find out these values. Okay, 1 upon T temperature you again obtain the slope, and due to that slope you obtain the b is equal to y2 minus y1 upon x2 minus x1. By putting this value in this equation, you can find out the dipole moment for the solid substances. Okay, that already we have find out that equation, that is molar polarization. Firstly we have to find out the different P2 values for the different temperature, and then we can we can draw the graph molar polarization for P2, molar polarization, that P2 is the molar polarization for the solid. Okay, that molar polarization of the solid at different temperature find out. Okay, for the solution we have to find out a different Pt. We have known that the molar polarization of the used solvent and its mole fraction and its mole fraction of the solute. And by obtaining these values, we draw a graph. From the graph, we obtain the values of the B. And by putting the values of B in this equation, you can find out the dipole moment for that solids. Okay, like that way we have seen the two methods. First method we have discussed, and that second method for the solids. Okay, for the solids, and solids you dissolve in the non-polar solvent such as CCl4 or benzene. Okay, like that number of solvents you dissolve it, and you have to replace the mass from M1 N1 plus M2 N2, and that we have converted that equation like that way. Then P2 at the one side, by using this equation we can find out the P2 and draw a graph P2 versus for the different temperature. You find out the P2 values, you take the P2 values versus 1 upon T. From the graph you obtain the B, and by putting the B's value of B, you can find out the dipole moment for solid substances. Okay, this is all about the methods for find out the dipole moment. Thank you very much.